Most people don't understand nuclear fallout, and that can get you killed. Intro. Why this matters. Most people think nuclear war kills you instantly. A blinding flash, a shock wave, and then nothing. But that's not how most people die. If you're not near the blast itself, the real danger comes later. Hours later, days later. It comes quietly. It settles onto the ground, onto rooftops, into clothing, into lungs. That danger is nuclear fallout, and most people don't understand how it works, which means they make the worst possible decisions at exactly the wrong time. This video is going to change that. We're going to break down the types of radiation that actually matter, what protects you and what doesn't, how fast fallout travels, and a realistic scenario, a nuclear detonation in Chicago and what happens 200 miles away in south-central Michigan. No fear porn, no Hollywood nonsense, just physics, time, and survival. Part 1. The 3 types of radiation. Let's start with the basics, because not all radiation behaves the same. Alpha radiation. Alpha particles are heavy and slow. They cannot penetrate skin. A sheet of paper stops them. If alpha radiation is outside your body, it's almost harmless. But, and this is critical, if alpha-emitting particles are inhaled or swallowed, they become extremely dangerous. Fallout dust often contains alpha emitters. So alpha radiation is not about shielding. It's about keeping particles out of your body. Beta radiation. Beta particles are lighter and faster. They can penetrate skin slightly, enough to cause burns with prolonged exposure. They're stopped by clothing, plastic, thin metal, several millimeters of wood. Beta radiation is mostly a surface exposure problem. Good shelter and basic barriers reduce it significantly. Gamma radiation. This is the killer. Gamma radiation is different. Gamma rays are pure energy. No mass, no charge. They pass through skin, clothing, wood, most walls. Gamma radiation is what kills people after fallout settles. The only thing that stops gamma radiation is mass. Earth, concrete, water, dense material. This is why basements save lives. Part 2. How shielding really works. Radiation protection is not all or nothing. It's about reduction. The key concept is the half-value layer. A half-value layer means enough material to reduce gamma radiation by 50%. Add another half-value layer, you cut it in half again. Here are realistic examples. 2.4 inches of concrete equals 50% reduction. 3.6 inches of packed earth equals 50%. 6 inches of water equals 50%. 11 inches of wood equals 50%. Stack them. 2 layers equals 75% reduction. 3 layers equals 87.5%. 6 layers equals over 98%. This is why a basement with earth on all sides, concrete walls, soil above, you can reduce radiation exposure by 10 times to 100 times compared to being outside. And it's why hiding in a car or upstairs room is a death sentence. Distance and mass save lives. Sealing cracks helps, but shielding matters more. Part 3. What fallout actually is. Fallout is not a green glow. It's not liquid. It's not gas. Fallout is radioactive dust and debris. When a nuclear weapon detonates, soil, concrete, buildings, asphalt are sucked into the fireball. They become irradiated. They cool, and they fall back to Earth. The largest particles fall first, close to ground zero. Smaller particles travel farther, sometimes hundreds of miles. Fallout is most dangerous after it lands. Radiation levels outside can be lethal, even though everything looks calm. This is why timing matters. Part 4. The Rule of Sevens. Radiation from fallout decays fast. This is one of the most misunderstood and most important facts. The Rule of Sevens says, for every 7 times increase in time, radiation drops by 10 times. Example: 1 hour after detonation equals 100% radiation. 7 hours equals 10%. 49 hours, approximately 2 days, equals 1%. 14 days equals about 0.1%. This is why sheltering early is critical. The first 24 to 48 hours are the most dangerous. If you survive those, your odds improve dramatically. Part 5. Scenario Setup. Now let's put this into a real-world example. A nuclear weapon detonates in Chicago. You are in south-central Michigan, roughly 200 miles away. You do not see the flash. You do not feel the blast. Your danger depends on wind speed, wind direction, weather conditions, terrain, particle size. Let's break that down. Part 6. How fast fallout travels. Fallout does not arrive instantly. It rides the wind. Wind speed matters. Typical wind speeds at altitude: 10 miles per hour equals fallout arrives in 20 hours. 20 miles per hour equals 10 hours. 40 miles per hour equals 5 hours. Jet stream winds can be faster, but most heavy fallout rides lower level winds. Weather matters. Rain can bring fallout down earlier and more concentrated. Dry conditions allow wider dispersal. Snow can trap particles temporarily, then release them later. Distance matters. At 200 miles, you are outside the heaviest fallout zone. Only about 10 to 15% of total fallout mass reaches that distance. But that 10 to 15% can still be deadly without shelter. Part 7. Timeline. Chicago to South Central Michigan. Let's walk the clock. Hour 0 to 1. Explosion occurs. Local chaos. You may hear rumors. Cell networks may still work briefly. This is your warning window. If you hear credible reports, you shelter immediately. Hour 3 to 6. Fallout begins landing downwind closer to the blast. Radiation levels near ground zero are extreme. You may still see nothing where you are. This is when people make the fatal mistake of waiting to see. Hour 6 to 12. If winds average 20 to 30 miles per hour, first fallout particles arrive in south-central Michigan. Radiation levels begin climbing rapidly outdoors. Still no glow. Still no smell, just invisible death. Hour 12 to 24. Radiation outside may peak. This is the most dangerous period. Being outside during this window, even briefly, can deliver a lethal dose. Basement shelter during this period is the difference between life and death. Day 2 to 3. Radiation drops sharply. You may be able to make short, controlled movements, adjust shelter, retrieve supplies from inside the structure, avoid outside exposure. Day 7 plus. Radiation has dropped by roughly 90 to 99%. Fallout is still present, but survivable with precautions. This is when recovery decisions begin. Part 8. The biggest mistakes people make. Waiting for confirmation. Fallout doesn't wait for certainty. Going outside just for a minute. Gamma radiation doesn't care about intentions. Over-focusing on sealing instead of shielding. Air leaks matter less than mass. Leaving shelter too early. The clock is your enemy, then your ally. Conclusion. What actually saves you? Nuclear fallout is survivable, not with bravery, not with luck, with early shelter, dense shielding, time, discipline. You don't need a bunker. You need earth between you and the fallout, patience during the worst hours, knowledge instead of panic. Radiation fades. Mistakes don't. If you want to survive the unthinkable, you prepare for the quiet part that comes after the blast.